Hello, everyone. This is Daniel Roy with Hivemind Technologies, and with me today is Fernando.
Hi, I'm Fernando. I am a security principal at Hivemind.
And today, this will be the first video in a series tackling IT security in modern software development in 2025. And today, we're going to be outlining some of the top challenges and vulnerabilities in modern software infrastructure. So, gone are the days of the massive monoliths running on bare metal servers stuck in the closet of the headquarters. Now everyone's doing microservices, cloud native microservices deployed to their cloud provider of choice. So these are typically Docker containers deployed to likes of Kubernetes and such like that. But Fernando, I want you to tell me what are some of the common vulnerabilities that we might find in these containers?
Well, that's a great question. It's actually a very wide range of things that can go wrong when you think about container vulnerabilities. Um, in our article series, we want to explore the different aspects that there are to modern cloud native infrastructure and how it can be secured. And one of which is directly container vulnerabilities, which can be attributed to, for example, misconfiguration, right? The default usually is secure enough, but when a developer or an operations engineer doesn't know how to configure their Kubernetes workloads, for example, they might not be aware of some of the options that they have to prevent, for example, container privilege escalations. And that can be mitigated through security context and specifying the user group and user IDs that can be run in the container. Not only that, but also scanning images. So, of course, an obvious one where one can use a container registry or some kind of tool to upload their Docker images to be scanned for known vulnerabilities in the software that is installed. That happens usually in third-party containers. But if you're maintaining your own container infrastructure, then it's responsible to have them start by scratch and then have regular scans on them, as well as continuously updating the results for those scans. For example, if a 0 day gets exposed or a vulnerability gets published with a known CVE, then just making sure that you comb through your infrastructure and see that any of your dependencies or containers use that library or piece of software and patching that up promptly.
There's a key topic right there you mentioned. So I'm a software developer, so I know full well we build microservices built on top of many libraries, many layers of different libraries that are built on other libraries and other frameworks. And just a few years ago, we had a massive scare with the Log4j vulnerabilities. It seemed like for that 1 week, the entire industry was in kind of chaos trying to patch this and update Docker images and such like that. And perhaps thanks to that scare, I have seen container scanning has become a lot more prevalent in industry. And again, yeah, this is something that we need to continually do. As new libraries, new updates for libraries come out, we have to keep scanning them. You talk about privileged access for APIs as well, and some is there potential that APIs can have too much access, and then once a malicious attacker gets access to one API, one service, they can gain access to the entire network.
Right. So usually I mean, if we're talking about a container being secure, we usually also think about how is it that it was compromised in the first place, right? And there's always an attack surface, right? That you can't get rid of it. If you have a public-facing interface or API, then you'll have some kind of attack surface. That's not a bad thing per se, as long as you're doing your due diligence to secure that attack surface and know the possible risks that having such an attack surface can might what it might entail. So having an API exposed to the internet can come to certain uh, can have you come to certain situations. For example, when usually, in my experience, developers only focus on making it work, right? And security is usually, unfortunately, in this industry, a
I've definitely
afterthought.
been guilty of that. I can agree.
So what happens is you might connect, I don't know, your API gateway, you have your domain name, you do your certificates, right? You make TLS work, and then that's it. and then you just connect it to your microservice. And it's usually hard to allocate or to think about how it is that you can secure it, because once it's exposed, it's live, and you want to keep going and keep building great stuff. But usually, an afterthought that happens to create a lot of problems is to not think about um, where your traffic is going to come from. So usually, I don't know, if your service is globally, like for example, geo-limited, so it might be a good idea to just re out of the gate, just block any kind of traffic that is not relevant to your users, right? So if you're, for example, serving users in the US, then you have no business responding to requests coming from any other country that is not that one. So that's one. The other one is rate limiting, for example. I'm going to say that again. One of them is rate limiting. So what happens is if your traffic is coming, let's say from the place which you're expected to come from, it can still be abused, right? People can fake their location almost always. And not having a rate limit or thinking about how fast you want to serve the requests might bring about denial of service attacks, right? So if you don't rate limit or become aware of how often a certain um, source is connecting to your API, then you might be vulnerable to a distributed denial of service attack because you're not really, well, implementing a rate limit would then prevent this. Because another aspect or consideration that you can take regarding your API security is rate limiting, right? Most of the time, if you're not aware of where your traffic is coming or how fast it is coming, and whether you can serve that traffic at that rate, you might be vulnerable to distributed denial of service attacks. So giving you to think and configuring appropriately in your API gateways regarding how much and how fast is it that you can serve your clients uh, will make for better will make for better decisions regarding securing an API gateway.
That's fascinating as well. And you talk about malicious attacks, and they can, malicious attackers can, yeah, feign their location in the world to gain access from geo-blocked locations. And one thing that always makes me laugh whenever you see in the movies, when you see hackers hacking into a mainframe, they're typically running some nonsense script with text flying across the screen, when in reality, most hacking still involves getting a hold of an individual, such as their laptop, an individual inside of the organization, their work laptop or their phone or something like that, cloning it or just outright stealing it, and then, you know, maybe forcing through a password, perhaps not a very secure password either. So are there ways that we can prevent these vulnerabilities, literally the hardware vulnerabilities, if an employee loses their laptop, um, that can help still maintain security of the system, even with this now exposed hardware access?
Sure. The article also dives into several topics that might overlap in this scenario. So one of which is zero trust, of course. Zero trust is a set of practices that require you to verify who is connecting from where and with what to your systems, right? One of which is the laptop itself. If it's stolen, then to mitigate the amount of access. So not because you have an employee's laptop doesn't mean that you have full access to a system. One should configure them not only in a MDM scenario, so managed devices, but also as in if somebody would get my laptop, they would still need my password. And if they have my password, they might have access to my SSH keys, but they would still need a password for those, right? Because they would either need a fingerprint or a password to be able to use them or harness them, right? So be thinking about the hardware that you're provisioning, what software is installed, and how often is it updated. And all these kind of policies cover most of the scenarios that might involve in losing a device. Now, if a device is not lost, but you have an insider threat, so an employee that is disgruntled, or maybe they didn't get their bonus, or I don't know, they decide to do something evil to your organization. Um, this is where monitoring comes into play. So behavioral analytics and monitoring within the organization. So any kind of erratic behavior and or privilege escalation of policies is what you want to think about. Because you want to make sure that your policies within your organization are properly tailored in the sense that they cannot be abused by escalation within those available resources in the organization. That goes, we have an article about IAM role misuse and privilege escalation that dives deep into the RBAC and IAM policy restrictions that you can put in place in your cloud or in-premise environment that can prevent any kind of lateral movement from either a third party that gain access to your system to a computer within your system, or a disgruntled employee or insider threat.
A wonderful point as well. And perhaps the last question I have for you today is all that we've talked about the microservices and services and stuff like that as well. But what about the perhaps much more sensitive issue of the databases that they're usually sitting in front of? They have secure data, and particularly in some organizations might have personal data they have to secure. Uh, what kind of issues that we can have? Well, database has been around a long time. We know about encryption, but what about when that data's in transmission from the database to services or even in between services? Can there be vulnerabilities there as well?
Well, historically, encryption at rest and encryption in transit have been concepts that have hopefully, at least in Hivemind or Hivemind clients, are ubiquitous. So we wouldn't recommend anybody to not follow some sort of encryption at rest and encryption in transit. That means using TLS for securing data on the go, right? But there's further technologies that can help you to ensure that that is a default and not a feature that is implemented afterwards, right? And one of which is using a service mesh, right? When you're talking about Kubernetes and microservices, deploying a service mesh ensures that all traffic coming from a container or a service is encrypted through a proxy and is immediately or by default then encrypted, right? Not only that, but it also brings a bunch of observability and metrics that you can then analyze in order to, make decisions regarding your architecture.
That's an excellent point. So I think as we've demonstrated here, Hivemind, we take security very seriously. And in fact, we even practice sec DevOps, which is an extension of the typical DevOps that puts security first as well during the initial design phases as well, and not, as you alluded to earlier, an after the engineers have got our little APIs all working together nicely. Security is first and foremost too. So we're looking forward to sharing more videos and articles coming up soon. Please check out the blog and our YouTube channel and other social media sites for those coming up in the coming weeks. So we can elaborate on some of these topics that Fernando has discussed with us today in greater detail. So thank you very much for joining me today, Fernando.
Yeah, happy to help.
And yeah, we look forward to hearing from you again soon. Thank you, everyone. Goodbye.